There is a $4 passive cooling system that drops an upstairs bedroom by 15 degrees on a 95-degree day with zero electricity and zero moving parts. It has no compressor, no refrigerant, no ductwork, and no monthly utility charge. The materials cost less than a tank of gas. In 1847, German immigrants in Lancaster County, Pennsylvania, built farmhouses that held 68 degrees on the second floor, while the roof deck above them baked at 130. Then the American residential HVAC industry scaled to $140 billion in annual revenue, and the building code committees that decide what counts as proper ventilation started getting their conference funding from the manufacturers, who need you to believe your house cannot stay cool without a 3-ton compressor on a concrete pad. This is the story of attic thermal management through radiant interception and passive convective exhaust. The utilities will not teach this in any homeowner seminar. Welcome back. Glad you are here. Long before anyone called it the stack effect, builders who worked with their hands understood that hot air moves up and cool air settles low. The Roman villa at Fishbourne in southern Britain, dated to 75 AD, used a hypercaust system under the floor to heat living spaces in winter, but the same architects who designed those hot air channels also built high clerestory windows in the atrium to exhaust the rising heat in summer. The principle was convection. Warm air expands, becomes less dense, and rises toward any opening you give it. In Korea during the Joseon dynasty, starting around 1392, the ondol underfloor heating system that kept homes warm in January was paired with high gable vents and ridge openings that allowed summer heat to escape before it radiated down into the sleeping rooms. By the time German and Swiss immigrants arrived in Pennsylvania in the early 1700s, they carried a building tradition that included the dachboden, a ventilated attic space with opposing gable vents, and a central cupola, or roof lantern, that created a continuous updraft. The Amish communities in Lancaster and later in Holmes County, Ohio, preserved that method without modification for 2 centuries. In the arid Southwest, adobe builders in New Mexico during the Spanish colonial period used vigas, the exposed roof beams, with small gaps between the planking to allow rising heat to bleed out before it soaked into the mud brick walls. In the Finnish countryside, the traditional 2-story log farmhouse included a tuuletusluku, a small hinged vent near the ridgeline that stayed open from May through September to prevent the upper floor from becoming an oven. Every one of these traditions operated on the same physics. Heat your attic, and that heat will radiate downward through your ceiling into your living space, unless you give it a path to escape upward first. In 1824, a French military engineer named Sadi Carnot published Reflections on the Motive Power of Fire, the first formal treatment of thermodynamic cycles. Carnot described heat as a fluid that flows from hot to cold, and while his caloric theory was incomplete, the principle he isolated was correct. Heat moves. It conducts through solid materials, it radiates across air gaps, and it convects when air itself carries the energy. 50 years later, in 1872, an American physicist named John Tyndall demonstrated that water vapor in air absorbs and re-radiates infrared heat far more effectively than dry air. This is why a humid attic on an August afternoon feels worse than a dry one at the same temperature. The moisture-laden air holds the heat and radiates it downward through your ceiling joists all night. In 1943, during wartime material shortages, the University of Florida Agricultural Extension Service published a study on natural cooling methods for wood frame houses in the South. The researchers measured indoor temperatures in identical farmhouses, one with a functioning cupola and ridge vent system, one without. On a 92-degree day in July, the house with the cupola held an upstairs bedroom at 76 degrees. The house without it reached 91. The temperature difference was 15 degrees, achieved with no fan, no electricity, no mechanical system. The cupola created a convective loop. Hot air rose into the attic, continued rising through the cupola opening, and drew cooler air in through lower windows and foundation vents. The system was self-regulating. The hotter the attic became, the faster the convection. In 1946, a Pennsylvania State University extension agent named Walter Schoff documented the same effect in a farmhouse near Ephrata. He measured a continuous 2-mile-per-hour breeze moving through the ground floor on a windless day. driven entirely by the temperature difference between the attic and the shaded north side of the house. Before I go further, everything I just shared is barely the surface. I spent months collecting the off-grid cooling and thermal management techniques the HVAC industry does not want you to know. Whole house convective loops, radiant barrier placement that costs $8
As you can see,
and cuts
the
attic heat by
Q3
30%.
projections are robust,
The trom wall,
despite the
winter
recent
summer
market
reversal.
volatility.
Evaporative
We
night
must move
cooling from a
quickly.
wet cotton sheet. The root cellar ventilation trick that keeps food cold in July with no refrigerator. Desert downdraft towers. All of it is inside vault name. Link in the description. But stay right here, because what comes next is going to make the air conditioning industry deeply uncomfortable. The American residential HVAC industry generates roughly $140 billion in annual revenue, according to trade data from 2024. The average household in the southern half of the United States spends $250 to $400 per month running central air conditioning from June through August. A typical 3-ton air conditioning unit pulls 3,500 watts at full load. Over a summer, that is 1,500 kilowatt hours, billed at 12 to 18 cents per kilowatt hour, depending on your utility. The system requires a licensed installer, a refrigerant certification, a concrete pad, a breaker panel upgrade in many older homes, and a maintenance contract that runs $150 to $300 per year.
This fourth
The
quarter
compressor has a service life of 12 to 15 years.
Here.
Replacement cost in 2026 runs $4,000 to $7,000 installed. Now consider the attic passive ventilation system. The materials are a roll of aluminum insect screen for $12, 4 yards of untreated cotton muslin fabric at about $1 per yard, a handful of galvanized roofing nails, and a handsaw if you need to enlarge an existing gable vent. Total cost, $15 to $20. Installation time is 1 afternoon. There is no compressor to replace, no refrigerant to leak, no service contract, no monthly bill. The system works as long as the sun heats your roof and the air inside your attic is warmer than the air outside. That is every day from April through October in most of the continental United States. The reason this method is not standard construction practice is that it generates zero recurring revenue. You build it once. It works indefinitely. There is no subscription. In the years following World War II, the suburban housing boom and cheap natural gas made central heating and later central air conditioning the
This growth
default
trajectory
in new
is
construction.
remarkable, gentlemen.
Carrier,
Indeed.
Train, Lennox,
The European
and
market
York
share alone
became
is
household
staggering.
names. The building codes that govern residential construction are written by committees that include representatives from industry trade groups. The International Code Council, which publishes the International Residential Code, adopted by most U.S. states, receives funding and technical input from HVAC manufacturers and their trade associations. In the 1970s, the code language around attic ventilation shifted. Cupolas and ridge vents were classified as optional aesthetic features rather than functional components. The minimum ventilation standard became 1 square foot of vent area per 150 square feet of attic floor, a ratio that sounds reasonable, but in practice creates almost no convective flow because the vents are placed low in the gable ends where the hottest air never reaches them. In 1980, the average new American house had attic ventilation that met code, but produced no measurable cooling effect. By 2000, cupolas had disappeared entirely from tract housing. The industry had successfully reframed passive cooling as a historical curiosity and active refrigeration as the only serious solution. Here is how you restore the system. Step 1. Inspect your existing attic. You need 2 things: a path for hot air to escape at the highest point, and a path for replacement air to enter at the lowest point. If your house has gable vents, they are usually located in the triangular wall section at each end of the attic. Most gable vents installed after 1970 are too small and covered with a fixed louvered screen that blocks more air than it allows. You are going to enlarge the opening and replace the screen. Step 2. Measure the gable vent opening. A functional vent for a 1,500 square foot attic should be at least 24 inches wide by 16 inches tall. If your existing vent is smaller, use a handsaw to carefully enlarge the opening in the exterior siding. Work from inside the attic, cutting through the sheathing and siding together. Wear a dust mask. This takes about 30 minutes per vent. Step 3. Cover the enlarged opening with aluminum insect screen. Buy a roll of 24-inch by 25-foot aluminum screen from any hardware store for about $12. Cut a piece 4 inches larger than the vent opening on all sides. Secure it to the interior face of the vent opening with galvanized roofing nails or staples every 4 inches around the perimeter. The screen keeps birds and insects out while allowing maximum airflow. Do not use the old-style louvered vent cover. It cuts airflow by 60%. Step 4. Install the radiant intercept layer. This is the piece that no modern builder will tell you about. Buy 4 yards of untreated cotton muslin fabric from a fabric store. Muslin is plain weave cotton, usually sold in 60-inch width, costs about $1 per yard. Total cost $4. Cut the muslin into 2 pieces, each large enough to cover 1 gable vent on the interior side. Soak each piece in clean water, wring it out until it is damp but not dripping, and drape it over the inside of the aluminum screen so the fabric hangs loosely against the screen surface. Secure the top edge with small nails or push pins into the wood framing around the vent. Let the fabric hang naturally. Do not stretch it tight. The damp muslin does 2 things. It absorbs radiant infrared heat coming off the underside of your roof deck, and as the moisture evaporates, it cools the air passing through the vent. On a clear night, the muslin will wick moisture from the cooler outside air and stay damp without any additional water. On a hot, dry day, you may need to re-wet it once every 3 or 4 days. 1 gallon of water will re-wet both pieces. Step 5. Create the low intake path. Go to your basement or crawl space. Locate the foundation vents. These are the small, rectangular openings in the foundation wall, usually covered with a metal screen or louvered cover. Open them. If they are nailed shut or painted over, pry them open and clean out any debris. You need at least 2 foundation vents on opposite sides of the house, each at least 8 inches by 16 inches. These are your intake vents. Cool air from ground level will enter here and flow upward through the house as the hot air exits through the gable vents. Step 6. Establish the convective path. Open 1 window on the ground floor on the north side of the house, the side that stays in shade most of the day. Open it 3 to 4 inches. Open 1 interior door on each floor to create a vertical path from the ground floor to the attic access hatch. If you have an attic access hatch, leave it open or replace the solid hatch cover with a louvered vent cover. The convective loop is now complete. Cool air enters through the foundation vents and the north side window, warms as it rises through the house, enters the attic through the open hatch, and exits through the gable vents. Step 7. Test the system. On a sunny day when the outdoor temperature is above 80 degrees, go into your attic at 2 in the afternoon. Hold a lit incense stick or a piece of smoke from a blown-out match near the gable vent opening. You should see the smoke drawn toward the vent and pulled outside. If the smoke hangs still or drifts downward, your intake path is blocked. Check that the foundation vents and ground floor window are open. If the smoke moves toward the vent but slowly, your vent opening is still too small or the muslin is blocking too much airflow. Adjust as needed. When the system is working, you will feel a noticeable breeze moving through the attic toward the vents, even when the outside air is calm. Step 8. Monitor the temperature. Place a simple indoor-outdoor thermometer in an upstairs bedroom and another in the attic. On a 90-degree day, a working system will hold the upstairs bedroom 10 to 15 degrees cooler than the attic and 5 to 8 degrees cooler than the outdoor air. The attic itself will still be hot, but the heat will be moving out instead of soaking into the ceiling and radiating down into your living space overnight. Total material cost, $15 to $20. Total installation time, 4 to 6 hours spread over 1 weekend. The system requires no electricity, no maintenance other than re-wetting the muslin every few days in dry climates, and no replacement parts. A single installation will function for years. The muslin fabric will eventually degrade from UV exposure if it is in direct sun. Replace it once every 2 years at $4 per replacement. 2 real-world use cases. For a 1,500 square foot ranch house with an uninsulated attic in North Carolina, this system will drop the second floor bedroom temperature by 12 to 15 degrees on a July afternoon compared to a sealed attic with standard code minimum vents. The homeowner in that scenario was previously running a window air conditioner 8 hours per day at a cost of roughly $60 per month in electricity. After installing the convective system, the air conditioner was needed only on days above 95 degrees, dropping the monthly bill to $15. For a two-story farmhouse in Ohio with an existing cupola that had been sealed shut in the 1980s, reopening the cupola and adding the damp muslin intercept layer brought the upstairs bedroom from 87 degrees at bedtime down to 73 degrees, making the space livable without mechanical cooling. One honest limitation: this system works by moving air. If you live in a climate with high humidity and nighttime temperatures that stay above 75 degrees, the system will still reduce the radiant heat load from your attic, but it will not make your house feel cool. You are moving warm, humid air, which is better than trapping hot, humid air, but it is not the same as refrigerated air conditioning. In those cases, the system reduces your cooling load and allows a smaller air conditioner to run fewer hours, but it does not eliminate the need for mechanical cooling entirely. One safety note: if you are enlarging a vent opening by cutting through your roof sheathing or gable siding, work carefully and watch for electrical wiring that may be running through that wall cavity. Turn off power to any circuits in that area before cutting. Wear eye protection and a dust mask. If your attic insulation contains vermiculite, which may contain asbestos, do not disturb it. Hire a certified abatement contractor to handle any work in that space. Roman architects knew it when they built clerestory vents into the atrium of the villa at Fishbourne. Korean builders knew it when they paired the ondol heating floor with high Gable exhaust vents. German immigrants knew it when they framed their Pennsylvania farmhouses with cupolas and ridge vents in 1740. The Amish preserved it without interruption for 200 years because their building tradition was not influenced by an industry that profits from monthly billing.
As you can see,
the American HVAC industry generates $140 billion per year by convincing you that comfort requires a compressor, a refrigerant loop, and a service contract. A $15 passive ventilation system that requires no electricity and no replacement parts does not fit that business model. Subscribe if this made sense. Share it with anyone paying $200 a month to cool a house that was built wrong on purpose. The next vault opens soon. Next time we are looking at the $12 solar chimney that ventilates a workshop in dead air, and the $40 night sky radiative cooling panel that drops a metal roof by 20 degrees after sunset. Thanks for being here.